projects. In this video, we are going to explain using deep learning to predict plant growth and yield in greenhouse environments. Introduction. Plant growth and production prediction are critical tasks for greenhouse farmers and agriculture in general. Developing models that can accurately predict growth and yield that can assist growers in improving environmental management for improved production, matching supply and market demand, and also lowering costs. Recent advances in machine learning, particularly deep learning, have the potential to give powerful new analytical tools. This project proposes the use of machine learning and deep learning approaches to forecast yield and plant growth variance in two different ficus stem development scenarios in controlled greenhouse conditions. In this prediction formulations, we use support vector regressor, random forest, long short-term memory, and extension feed-forward MLP neural network. Coming to objective, goal of this project is to develop and compare machine learning and deep learning algorithms for predicting yield and plant growth variation in controlled greenhouse environments. The goal includes forecasting yield and growth, developing analytical tools, improving environmental controls, and optimizing market demand and costs, and also contributing to agriculture. This project intends to use ML and DL approaches to create models that can efficiently anticipate ficus plant development, optimizing environmental control and reducing expenses, and also maximizing revenues. Growers can better manage production cycles and avoid overproduction or shortages, and also contribute to progress of agriculture method by anticipating plant growth and yield. These are the requirements for execution of the project. In hardware requirements, operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above are needed. In software, we need Python IDEL of 3.7 version. These are the algorithms used in the execution of the project. First one is support vector regressor. It is a supervised learning algorithm that is often used for regression tasks. It is particularly effective when dealing with non-linear relationships between variables. SVR works by finding a hyperplane that best fits the data while minimizing the margin of error. It can handle high-dimensional data, and that can be effective where there is limited amount of training data. Here, SVR is used in this project to capture complex relationships between environmental factors and plant growth yield. Second one is random forest. It is an ensembling learning algorithm that combines multiple decision trees to make predictions. It's well suited for both classification and regression tasks. Random forest can handle non-linear relationships and interactions between features and noisy data. It is known for its robustness against overfitting and its ability to handle large number of input features. Random forest is used in this project to capture combined effects of various environmental conditions on plant growth and yield. Third algorithm is long short-term memory algorithm. LSTM is a type of recurrent neural network designed to model sequences and time dependencies. It's particularly effective for tasks involving time series data, where the temporal relationships between data points. LSTMs can capture long-term dependencies and are capable of handling sequential patterns. In this project, LSTM is used to model temporal aspects of plant growth and yield, considering the factors like changing conditions over time. Last algorithm is extension feed-forward MLP neural network. Feed-forward multi-layer perceptron neural networks are versatile and widely used for various machine learning tasks, including regression. They consist of layers of interconnected neurons that process input data and learn complex patterns. By adjusting the architecture and hyperparameters, MLPs can model nonlinear relationships and interactions between the features. The extension aspect suggests that we have possibly introduced modifications or enhancements to the traditional MLP architecture. This is used in this project because to leverage the power of deep learning and capture intricate relationships in the data for accurate predictions. Coming to methodology, we have designed these 8 modules for execution. First one is upload ficus plant dataset. In this module, we will upload ficus plant dataset to the application. Second one is data preprocessing. This step involves preparing the dataset for training and testing models. It includes tasks like data cleaning, feature selection, normalization, and splitting the data into training and testing. Third one is run SVR algorithm. Support vector regression is a traditional machine learning algorithm used for regression tasks. In this step, SVR is preprocessed and then this algorithm will be implemented on the trained data and then it will predict it on the test data. Similarly, we will run random forest algorithm, LSTM algorithm, and extension feed-forward MLP neural network algorithm. And then in the 7th module, which is predict plant and yield growth, in this we will upload the test data and then predict the plant growth. Last module is MAE, MSE and RMSE graph. In this, we will compare all the algorithms MAE, MSE and RMSE graphs. For execution of the project, first we need to open the code folder. This is the code folder of the project and this is the dataset folder. On this dataset, we will be building the models. These are the parameters of the project, which are CO2, radiation, diameter, humidity, outside temperature, inside temperature, measurement and yield. And this is the test data set. For this test data set, we will be predicting the models. And this is the model file, which contains the .h5 file stored in it, which contains the algorithm information. This h5 files can be loaded into the project code during runtime to utilize the train models. And this is the run.bat file. Instead of executing the project in command line interface, we have created Windows batch file for execution of the project. And this is the main code file. We need to double click on it for execution of the project. This is the graphical user interface of the project. With this, we can interact with the program. And this graphical user interface is created by using Tkinter library in the Python. So first we need to upload the dataset. For this, we need to click on this button, upload Ficus plan dataset. Here I will select Ficus data and click on open. Dataset is uploaded. Training records in this data are 4028 records. Now we need to pre-process the data. For that, we need to click on the button data pre-process and clean and train test split. Here dataset is normalized and here data cleaning process is completed. So data is split into train and test, where the train length is 3222 and test length is 806. Now we need to build the algorithms. First, all the algorithms will be training the model on this particular data and then it will predict it on this particular data. Now I will click on the button run SVR algorithm. Here SVR training process is completed and here we got the mean squared error, and also root mean squared error and mean absolute error for support vector regression algorithm. Now we will run the random forest algorithm. Here we got the MSE, MAE and RMSE of the random forest algorithm. Now we'll click on the button run LSTM algorithm. Here we got LSTM algorithms mean squared error, root mean squared error and mean absolute error. Now we'll click on the button extension feed forward MLP neural network algorithm. Here we got the extension feed forward neural networks mean squared error, root mean squared error and mean absolute error. Now we need to predict the plant and yield growth. For that we need to upload the test data. For that we need to click on the button predict plant and yield growth. I will be selecting the test data and click on open. Here data is predicted. For this record, it is predicted. This is the predicted yield growth. And for this, here is the predicted yield growth. And for this, here is the predicted yield growth. Now we will be comparing the graphs of all the algorithms. First, I will click on the button MAE graph to compare the mean absolute error of all the algorithms. Here on x-axis, MAE of all the algorithms are represented, which means this is the SVR algorithm, this is random forest, this is LSTM and this is extension of MAE. And y-axis is the MAE's code values. Among all the algorithms, the error rate for LSTM algorithm is very less. Now we'll click on the button MSE graph. Here on x-axis we have algorithm names and on y-axis we have the MSE scores. Among all the models, extension MSE error is very low. Now we'll check with RMSE graph. Here on x-axis we have all the algorithm names and on y-axis we have the RMSE scores. Among all the algorithms, extension RMSE is very low. If the error rate is very low, that model will be performing well. So close this GUI. Conclusion. Extension feed-forward MLP neural network algorithm obtained the lowest RMSE value for all the algorithms tested for predicting yield and plant growth variation. Its controlled greenhouse conditions for ficus stem growth. This suggests that it has potential to be very powerful tool to precisely predicting plant growth and output controlled greenhouse circumstances. The creation of accurate predictive model for plant growth and productively it is critical for greenhouse farmers and agriculture in general. Growers can optimize environmental controls, match production with market demand, and minimize expenses while ensuring higher crop production and quality with exact projections. This initiative contributes to the progress of analytical tools in greenhouse agriculture by harnessing the capabilities of ML and DL approaches, which are machine learning and deep learning, providing growers with a data-driven experience.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.